So in today's lecture, we try to find in the previous lecture we talked that how every domain they are related with the IP addresses. So so the IPv4, the private spaces, as you know, there are not enough public IPv4 addresses to assign a unique address to each device which is connected to the internet. So the networks are commonly implemented using the private IP addresses, and as defined in the private IP address range of classes. Can you please tell me, we have talked about uh, the IP version 4, where class A, class B, and class C IP addresses uh, with their range. Can you tell me what is class A, class B, class C IP addresses which we use? Private IP addresses. Yeah, yeah. The first one starts with 10 dot, then your 0 dot, 0 dot, 0. Correct? It starts with this and ends with your 10 dot, then you find 255 dot 255 dot 255. Similarly for class B, super, it is 172 dot 16 dot 0 dot 0 and ends with 172 dot 1 sorry 31, started with 16, okay, 31 dot the broadcast address is 255 dot 255 dot 255. Similarly for class C, it takes first 2 bytes completely, right? First one is 8 bits, second one is 12 bits, then 16 bits we use for network addresses. So it starts with 192.168 dot your 0 dot 0 and ends with 192.168 dot 255 dot 255. So these are the private IP address ranges we used. So these private addresses are used within an organization or site to allow devices to communicate locally. So, however, because these addresses do not identify any single company or organization, right? These are used for your private devices inside. So the private IPv4 addresses that cannot be routed over the internet. It is within the organization itself. So to allow a device with a private IP address to access devices and resources outside of your local area network, that means outside the range of these private IP addresses, right? So the private IP address must first be translated to a public IP address. So these private addresses should be translated to, call these as your private, should be translated into your public IP addresses. So then only any device, suppose if you have computer 1, or suppose the laptop 1, or suppose a server 1, within one organization, and suppose they are connected with the help of a switch, so they can communicate each other by using these private IP addresses. But if they want to communicate with any of the device which is outside the, suppose server 2, through your internet to these devices, the private IP address limitation is up to here. So here the network address translation is required to convert these private IP addresses to your public IP addresses. So this network address translation that provides the translation of private addresses to your public addresses, as shown in this diagram you can see, So this allows a device with a private v4 address to access resources outside of their private network. So that can be shown as this. So in private IP address space, as we saw, the device is connected here. If they want to communicate through internet, it requires the public IP addresses, right? So this NAT basically allows, which combines the private IP address that has the primary method of preserving the public IP address. So a single public IPv4 address can be shared by the hundreds, even thousands of devices inside this private network. So that means from this router, it can connect a range of hundreds or thousands of devices. But when from this router, when packet is going, there is single IPv4, that is public IPv4, is enough. That will be shared. So this in this case, the router which plays an important role to connect the internal network with the external network, the internet one. So without NAT, the network address translation, the it is not possible for the IPv4 address space would have occurred well before the 2000 years. But however, this NAT has some limitations and disadvantages, which will be explored later in this, the lecture session. So that is the important part of your NAT. So what is the basic definition of your NAT and what is the functionality and operation of your NAT? If you see here, NAT has many uses, but its primary use is to convert or conserve the public IPv4 addresses basically. So it does this by allowing the networks to use the private IPv4 addresses internally and providing the translation to a public address only when it is needed. Because if these devices wants to communicate with the external devices, then only the translation is needed. If these devices try to communicate inside or internally, they don't need of your public IPv4 address here. So NAT enables the router, which is we also called as your edge router. This is private network and public network. Whatever the first router is there, we call that as your edge router. So this NAT that enables this border router or your network edge router, we say. So that router can be configured with one or more valid public IP addresses. That is based on the load of this network. So these public addresses are known as the NAT pool. We used to call them as network address pool. So this router, if you consider this R2 is a border router of this private network, it may use a single IP address that, for example, suppose 201.201.50, or it can use the pool of addresses. Another IP address may be like 195.172.200.5 or like that. It may use either single or it may use a pool of addresses. So we call that network address pool. Right? So when an internal device sends traffic out of the network, the NAT enables the router translates the IPv4 address of the device to the public address from the network address translation pool, from this pool. But if they communicate inside, then there is no work of this router, because all the packets will be inside the network itself. So at NAT router typically operates at the border of your subnetwork as said. So a subnetwork is one or more networks with a single connection to its neighboring networks, which are the border router of other networks. Okay, or one way in and one way out of your network. So in this example, the figure 2, we can say, is a border router as seen from your internet service provider, R2 from a subnet, the subnetwork. So in this case, when a device inside the subnetwork of this, any of this network, the subnetwork of this, which only the exit point of the network here. So this subnetwork device wants to communicate with a device outside of its network. The packet is forwarded to the border router, and the border router performs the network address translation process and translate the internal private address of the device to a public or outside or the routable addresses. So here we need to note one thing is the connection to the internet service provider of this network that may use a private address or a public address that is shared among the customers. So for the purpose of this module, we just consider the public address as shown in this case, which is used for this line. For this line, we use the private IP address, but the outside line, the output interface, we use the public IP address. Right? So then how this network works, or how this NAT works. So let us consider that in this diagram, if you see that the PC1 with the private IP address 192.168.10.10 is the private IP address of your PC1 in this case, and this PC1 wants to communicate with the outside web server of having the IP address of your 209.165.201.1. So in this case, when a packet is generated, suppose packet generated by this PC1, it will go through your router R1. So in network address translation table, it will maintain the inside table and outside table entries. So inside local area network is 192.168.1. When this packet is going through the outline or the inside the global of that, then it is going through the outline public IP address, that is 209.165.200.226 line. So this is the translation from private to the public one. And when this router is connected to another router, that router interface inside line is this one, 209.165.200. This address, and the outline interface IP address is 209.765.201.1. And when it goes through this router, it will reach to its outlink, which is connected to a server which is having the public IP address of your 209.1. So only the translation is done at the border, the router part. So this is how the IP address translation done from your private IP address to your public IP address. So in this case, how this, along with the IP addresses, you will have the port numbers also, which belongs to your transport layer. So how those port addresses will be, what you call the translated. So this port addresses translation, similar like your NAT, network address translation, there is a port address translation, which is also known as your NAT overload, we say. So that maps the multiple private IP addresses to a single public IPv4 addresses or a few addresses from your pool. So this is what most home routers do. But the internet service provider assigns one address to the router, yet several members of the household inside that routers, they can use the same IP address as a public IP address. So as said, yet several members of the household can simultaneously access the internet. So this is the most common form of your network address translation for both the home and the enterprise enterprises or enterprise for connecting with the internet. So this, with this part, the port address translation, the multiple addresses can be mapped to one or to a few addresses because each private address is also tracked by a port number. So when a device initiated a TCP IP session, it may use port number 21, port number 22, or port number 23, or port number suppose 53, port number 443, for different use purpose. For FTP, for Telnet, for SSL, different port numbers will be used. So when a device initiates a TCP IP session here, it generates a TCP or UDP source port value or a specially assigned the query ID for your Internet Control Message Protocol, ICMP, to uniquely identify the sessions. So when the NAT router receives a packet from the client, it uses its source port number to uniquely identify the specific NAT translation. So this PAT entries, the port address translation ensures that devices use a different TCP port number for each session with a server on the internet, but when a response comes back from the server, the source port number, which becomes the destination port number on the return trip, which we observed in the previous sessions. So every the router or the border router, they maintains the NAT table with the overload. With the overload, we call the overload means along with the private IP address to your public IP address, they also maintain the port numbers. So these we call the merge, combined together. Okay, so that is what we have observed. How these IP addresses and port numbers are, they concatenated to, give the port concatenation part address of that. So in this what you call the port address, you can see this. There are two devices which are inside using the IP addresses, and they are using different TCP or UDP services. One is those services identified with which port number they are having, and what is the inside global IP address and what is the outside global address. So outside global address using the port number 80. So 80 port number is used for which TCP service? Is it the 80 port number? HTTP. Correct. That means the request which is from your PC1 and PC2 going to your server 1 or server 2, those servers are, we call the web servers. Because HTTP web pages are, the request is used to get the web pages. So further, this is the important of your network address translation. So in this case also, if you observe these services, do you find is there any possibilities of attacking the router R2? If your router R2 is compromised, suppose, by the attacker. So the attacker can act as a legitimate PC inside the subnetwork and try to interact with the other by using those private IP addresses and the inside global IP addresses. So on the internet side, they believe that the request is from legitimate users. Request is so when configuring the network to make secure your network, the configuration of router R2 or gate router is most important. So when we talk about the security infrastructure, there we talk more about this one. So the next, which we are saying is the file transfer or file transfer and sharing services. So what are the different file transfer sharing services provided by the application layer? FTP is one application, correct? And the extension of FTP is the TFTP, right? Okay, so these are two different services which we used. Okay. So in transmission control protocol, it provides two services, TCP and UDP. And UDP's transport layer UDP service is basically given for the what kind of application requests. Is it basically for broadcasting, searching purpose, like a domain name system service. You just give the cisco.com and it will go through the internet. There is no particular that. So if you recall that what are the different application services supported by different layers of TCP IP suite. If you recall that, you can remember that. So this is another set of applications of your TCP IP suite. One is your FTP, another one is your TFTP. So this file transfer protocol is another commonly used application layer protocol, right? So this FTP was developed to allow for data transfer between a client and a server, basically. Client will send the request and server will respond for that request. So an FTP client is an application that runs on a computer that is used to push and pull data from and your FTP servers. So this FTP application which runs on the client, can you know any of the applications, FTP application which runs on this client? To upload a huge volume of data on server, or you can retrieve a huge volume of data from the server. Did you heard a terminology PuTTY? PUTTY. That is one FTP application which runs on client. You might have heard about FileZilla. Is another application. So when this FTP service required by any client needs to run the application, FTP application.
How do you use SSH?
Yeah.
You can do FTP.
You can use FTP for that also. So those are few applications. If you name that, one is PuTTY, another one is FileZilla. There are many other applications are there called the FileZilla. So these are applications will run on the client. So when these applications run on the client, these applications, need the basic requirement is the IP address of this server to connect. Right. So as see in your in this figure, So there is a client and server, they are connected through the network. So to successfully transfer data between your FTP server and your client, the FTP requires two connections basically between the client and the server. One for the commands and replies is first connection that comes from your client, right? And the other for the actual file transfer. So first the connection establishment, that is the commands and replies used or control messages will be exchanged, and the second connection is used for your data connection. So in the first one, the client establishes the first connection to the server for control traffic using TCP port number. It used the port number 21, that is for FTP, that consisting of client commands and server replies in this. And the client establishes the second connection, this we call the data connection, or this second connection to your server for the actual data transfer using the TCP port number 20. For FTP connection establishment, it used the port number 21, and for actual data transfer between your client and server, use the port number, TCP port number 20. So this connection is created every time there is a data to be transferred. The data transfer can happen in either direction. In this case, the client can download or pull data from the server, or the client can upload or push data to the server. So this FTP was not designed to be a secure application layer protocol actually. This simple FTP part. It is not having any security because that any data can be captured by any other layer. So for this reason, the SSH file transfer for secure socket layer SSH file transfer protocol, which is a secure form of your FTP for file transfer, the protocol that uses the secure cell protocol to provide a secure channel. So is the preferred file transfer implementation actually. So based on commands sent across the control connection and the data connection to upload and retrieve the data, this is the general architecture which looks like. So in this another file transfer is your trivial file transfer protocol, is a simplified file transfer protocol that uses the well-known user-defined, the UDP port number 69. So this TFTP is a simplified one which uses this 69 port number, UDP port number. It is not TCP port number. So UDP port number means what? The 69, the connection between your client and server is not established. That is not a requirement. Pre-handshaking process is not required. So it lacks many of the features of your TCP FTP one, that is the pre-handshaking process to establish the connection, such as the file management operation of your listing, deleting or renaming the file. Because of its simplicity, this TFTP has a very low network overhead and is popular for non-critical file transfer application. So it is fundamentally insecure, however, because it has no login or access control feature. So for this reason, TFTP needs to be implemented carefully, and only when absolutely necessary, then only required to establish TFTP connection for your uploading the data or downloading the data between your client and the server. So in this case, the another feature for your what you call the sharing the information between your client and server, we call SMB, this file transfer and sharing service of your SMB. So this we call the server message back is a client server file sharing protocol. So SMB request and SMB request will be there from your server. So this protocol that describes the structure of the shared network resources, such as what are the directories, different directories are there in the network resources. So that is files, printers, the serial port, as you can see, the file system, printers, the mail slots, APIs, or which directories are in the shared mode, so that anyone can access that. So this format uses a fixed size header that is followed by the variable size parameters and your data components in this case to identify. So these SMB messages can start, authenticate, and terminate the sessions. So control files and your printer accesses in this case, they require the authentication process. Only authenticated users can access these files which are shared in the network by your server. So which allows the application to send or receive message to or from another device. So this SMB file sharing and the print service have become the mainstay of your Microsoft networking. Basically, that you can see in this case, if there are two different clients are there, if they are trying to share the information, they can use this Microsoft networking for copying file from one device to the another device. You can select as one set of files and you can share directly it with any other. So a file may be copied from your PC1 to your PC2 by using this service, the server message back service. So this is another important the service which is used by your network. So let me just recalling you that for sending the information, it is difficult for any human being to remember the private IP addresses. So one need to interact with any of the organizations. It requires a domain name system. So that we have discussed how the IP addresses are associated with the DNS as well. Second, another network service is your FTP. I mean the network address translation. When the device is trying to interact inside the network, they don't need any public IP address. But if any device inside your internal network to communicate with any external network, it requires a public IP address. So that public IP address provided by your internet service provider to a router which is known as a border gateway router or the network edge router. So these public IP addresses may have a single public IP address for any router or a pool of addresses. That depends on what is the load of that router. If the number of devices are less, then it may use single. If number of devices are more in that organization, it may use multiple IP addresses. So that NAT table will be maintained by your network router. And then for sending the or providing service for the applications such as your file transfer and your file transfer, because there is a possibility of send a huge volume of the data to your server, that is more than GBs or that. If you try to send the file without using FTP, it is difficult because it consumes more network bandwidth. In that, FTP connection is established so that a huge volume of data can be transferred in a short duration of time. For that, the network provides a service, FTP. Along with that, that FTP connection established by TCP layer. So that TCP layer either use the TCP segments or the UDP datagrams. If it use the TCP segment, it use the port number. For connection control, it use the 21 port number. For data transfer, it use the 2020 port number. If it is using the UDP means, if unsecure connection is supposed required to establish, then the TFTP can be used. That TFTP service utilizes the TCP's UDP service. TCP IP suites UDP service use the port number 69. That is one way. Another way of just copying a huge volume of data from one PC to another PC, you can use the SMB server message back network service. So another network service to transfer files from one device to another device is your email service. Your email service. Okay. So in this email service, it uses the email protocols. So what are the different email protocols that basically use? One of the primary service offered by the internet service providers, the ISP mail servers, ISP, they provides the email hosting. So to run on a computer or other end devices, email requires several applications and services. So in this figure, if you see what are the different other services provided by this ISP email servers, SMTP or IMAP or POP services are provided for email exchanging. So email is a store and forward method of sending, storing, and retrieving electronic messages across the network. So it has 3 steps. It will send, that will store, and then it will retrieve the electronic message across the network. So email messages are stored in the database on email server. It is connected to it will store in the email server first. So that is sending from here, and that will store in the email, and after that it will be retrieved from the email server. So there is a 3-step process. So email clients communicate with the email server to send and receive emails in their domain. Okay. This is a sender and the receiver side. So both are having connected to their internet service provider of your mail server. So the sender will send the email of the recipient that will go in terms that will utilize a application SMTP, and using that SMTP the email will store in the email server, and after that will be forwarded to the destination email server, and your recipient can retrieve that email from this email server later on. So that is store and retrieve. So this email server communicates with each other email server to transport messages from one domain to your another domain. That means if you recall, if you send any mails, you will have the to and from. It is not necessary that both the users have the same domain. You can write, in this example, suppose if I want to send any mail, generally we write that, in to field, we write that, suppose R1 who is the recipient at cisco.com. So domain is different from, suppose Raj at utsa.edu. So they are two different servers, right? One server is your .com server domain, another server is your .edu server. So first when Raj tried to send an email, that email go and store in the UTSA.edu or .edu Internet Service Provider server. And after that, that will retrieve from that .edu server and forward it to the destination domain, that is .com server. From that .com server, it will go to the recipient. So email supports 3 separate protocols for the operations. For these operations, what are those? As we said, one is SMTP, Simple Mail Transfer Protocol. So first service it used the Simple Mail Transfer Protocol, and after that it used the Post Office Protocol, and then finally it used either Post Office Protocol or your IMAP, this protocol. So the application layer process that sends email that uses this SMTP service, and on delivery side either it can use the POP service or IMAP service. Okay. So client retrieves the email using one of the 2 application layer protocols, either IMAP or your POP. So let us talk about what is basic functionality and operation of your SMTP. What happens on the SMTP side, sender side. So this SMTP message format that requires a message header and a message body. It will have the header. In any message, it will have the message header and the message body of that. So while the message body can contain any amount of text, the message header must have a properly formatted recipient email address and a sender address. That is what we have seen, the to and from addresses. When a client sends a mail, the client's SMTP process connects with the server SMTP process on well-known port number. We call 20. The port number which is used here is 25 port number for sending the email to the SMTP server. So the port number for this email SMTP application services using 25 port number. So after the connection is made between your sender and the servers, the client attempts to send the email to the server across the connection. So when the server receives the message, it either plays the message in a local account if the recipient is local. That means if they are in the same domain, like .com or .edu in the same domain, then you can place it in the local, or it forward that message to another mail server for delivery. That is what we have sent. If they are in the same location, suppose if this is a .com server, if the sender and recipient, if both are in the same domain, suppose, then it can simply forward that to another user in the same network which use the .com. If the sender, the recipient is in different domain, suppose, like I said, the edu server, then it will simply forward that SMTP packet to your edu server. So edu server will keep that copy and it will forward to the recipient side. So the destination email server may not be online or may be busy when email messages are sent. So therefore, SMTP protocol that spools the messages to be sent at a later time. So periodically the server checks the queue for messages and attempts to send them again if the message is still not delivered after a predetermined expiration time. So it returns to the sender as undelivered. That is what we generally find the message errors basically, right? So that is until it delivers for predefined mails or your predefined time is required, and within that time if it is not delivered, then it gives the message as your undeliverable. So then comes to the next application on receiver side. So the receiver side application, you're having the POP, the Post Office Protocol 3, is used by an application to retrieve email from the mail server. So with this POP application layer service, the mail is downloaded from the server to the client and then delete on the server of when it is delivered, then that will be deleted from this server, so that the space will be become available for other upcoming emails. So when the server starts the POP3 service by passively listening on the TCP port number, it used the port number for delivery. It used the port number 110 port number. For SMTP, to receive the email, it used the port number 25. And this POP, for delivering the email, it used the port number 110 from the delivery server. So when a client wants to make use of the service, it sends a request to establish a TCP connection with the server. When the connection is established, the POP3 server sends a greeting, and the client and POP3 server then exchange commands and responses until the connection is closed or aborted. So with this, POP3 email messages are downloaded to the client and removed from the server. So there is no centralized location where email messages are kept. So because POP3 does not store messages, it is undesirable for a small business that needs a centralized backup solution for this. So next, another service for delivering the message which we are using is your IMAP email service protocol. So in this case also, the sender used the mail service, that header and your body of the text, and use the port number 25. And then for IMP service, for the POP service, it used the port number 110. So this IMP is another protocol that describes a method to retrieve email messages like POP3, the delivering the email. So unlike the POP3, when the user connects to a IMAP capable server, that copies of the messages are downloaded to the client application. So it keeps the copy, and one copy sent to or delivered to the recipient. So the original messages are kept on the server until manually deleted, or users view the copies of the messages in their email client software. So users can create a file hierarchy on the server to organize and store email. So that file structure is duplicated on the email client as well. So when a user decides to delete the message, the server synchronizes that action and deletes the message from the server. So that is the difference between your IMAP and your POP3. So these both are used for delivering the email, but only difference is for IMAP it keeps the original message at the server and one copy goes to your recipient, whereas POP, as soon as that email is delivered to recipient, that is deleted from this server. So these are the basic email services. And another network service which is provided by your network is HTTP service. So as we know this HTTP server, so there are the application layer specific protocol that are designed for common uses such as web browsing and your email type. So either the web browsing can be done or the emails can be sent. So for emails, as we are using the SMTP, or your for delivering that and destination side, it use the POP3 or your what you call the IMAP. So the first topic gave you an overview of this protocol. That this topic goes into the more details of your how the actual data is transferred between your source and the destination or client and server. So when a web address or the uniform resource locator, we call the URL, or your web addresses are used, these are typed into a web browser, and the web browser establishes a connection to the web service. Then the web service is running on the server that is using the HTTP protocol, basically. So to understand that, you just open the browser and just check it out how it goes, and in day-to-day life we generally do that. But in the browser concept, as what we are saying, in the step 1, the browser interprets the 3 parts of the URL here when trying to browse this request in terms of your HTTP. First is, in step 1, the browser interprets, as said, the 3 parts of your URL, that is HTTP, the protocol and scheme which it is using, whether it is using the HTTP or HTTPS, which service it is using. And second one is, the first part is the second part, it is checking the domain, that is the server name. And third, it uses in the index, it is using the specific file name which is requested, that is HTML file name. So the browser performs these 3 operations separately. Then in the second step, once it interprets these 3, then the browser in the second step, the browser then checks with a name server to convert the address, that is the cisco.com, www.cisco.com, into a numeric IP address. It is trying to convert that into the numeric IP address, which it uses to connect to the server. So here this DNS is used. So domain name to the IP address, that is numeric IP address, will be converted. That is, the client initiates the HTTP request to get the requested server file in this step. So what happens here? The client initiates this HTTP request to a server by sending a GET request to the server and ask for the indexed HTML file. It asks the indexed HTML file. So that request page goes to your server from your browser to your server side. Second step. So in the third step, once it is requested, then in the third step, in response to that request page, the Cisco www.cisco.com page, the server sends the HTML code. Server sends the HTML code which is written for that particular request for this web page to the browser. That will go back in response. It will send that back to the client browser. So in the fourth step, the browser that decipher the HTML code and formats the page for the browser window that is in response of this. So this HTML code further decipher to the HTML formats of that web browser. So this is what happens in the hypertext or the transfer protocol or hypertext markup language. So in this, the HTTP and URL playing a major role. HTTP and the URL. So in this, if you talk about the HTTP and the URL, the HTTP URL can also specify the port on server that should handle the HTTP methods. So that we'll see how it will handle the HTTP methods. So in addition, it can specify a query string and fragment. The query string typically contains information that is not handled by the HTTP server process itself, but is instead handled by another process that is running on the web server. So query strings are prescribed by a question mark actually. In the query string, they're prescribed by this question mark or the question mark character, and typically it is consists of a series of name and value pairs. So name and the value pairs will be used. So a fragment is preceded by the hash character. It refers to a subordinate part of the resource that is requested in the URL. So for example, a fragment could refer to a named the anchor in the HTML document, suppose, then the URL will access the document and then move to the part of the document specified by the fragment if a matching named anchor link exists in that document. So, and the HTTP URL that includes these parts as showing in this case, the first it uses the scheme or the protocol, whether you are using the HTTP or HTTPS, and then it is followed by the domain. So example .com or .edu or .in or .us, and then followed by the port number that we call port binding, and that is followed by the path which is requested by your client, which is followed by query and fragment part. The query starts with the question mark or preceded with the question mark, and fragments start with the hash controller. Okay, so this is the general parts of your HTTP and URL of any given request from a client. So this URL says to the use the access the server at this example using this port number 8080. So that is your HTTP service. From the sounds directory, return the document with the ID. This document ID is 973285 and its format is your MP3 format and its fragment is 00M00S. So this is the position or the minutes and the seconds that the start of the file of the second. So this is the combination of your HTTP and the URL. So this service also provided by your network service of your TCP IP suite. So if you check the HTTP operation for understanding, in this HTTP operation, the HTTP is a request response protocol. HTTP operation, requesting, for that request the response will be given. So this request and response protocol that uses the TCP port number your 8080, or we can say that 80 in short form. So although other ports can be used here, but basically for request and response it uses the TCP port number 80. So when a client, typically a web browser, your client are typically the web browser, or web browser that sends a request to a web server, it will use one of these 6 methods that are specified by the HTTP protocol. They can use the get, post, put, delete, and some options and the connection. In the get service, or in the get method, a client request for data, a client, that is the web browser, sends the get message to the web server to request the HTML page, or any HTML page. And in the post method, it submits data to be processed by the resource. Where put method, it uploads a resource or content to the web server, such as your, it may be like image type. And in delete, this deletes the resource which is specified, and the options that returns the HTTP methods that the server supports, and where the connect method that requests the HTTP proxy server, any HTTP the proxy server that forwards the HTTP TCP session to the desired destination. So although HTTP is remarkably flexible, it is not a secure protocol, the HTTP. So the request message send information to the server in plain text that can be the intercepted and read by any of the attacker. So the server response, typically the HTML pages are also unencrypted here. So for that, it uses different codes. The HTTP status codes are used whether the information is reached or not, whether accepted by the server or not. So HTTP server responses are identified with various status codes that inform the host application of the outcome of your client request to the server. So the codes are organized into the 5 groups, like 1xx, 2xx, 3xx, 4xx and your 5xx groups. So which indicates the 1xx indicates the information, 2xx indicates the success, 3xx indicates the redirection, 4xx indicates the client error, 5xx indicates the server error. So, an explanation of some common status codes that you can see in this example. 1xx means it gives the information, and there is a code it uses the 100. So this xx replaced with 00. So the status is continue the service. So the client should continue with the request, and the server has verified that request can be fulfilled. If the code consists of 2xx, that service like 200, then the status code for this HTTP service is okay, the request is completed successfully. And if it use the suppose 202 code, that is 2xx here, so that is accepted. The request has been accepted for processing, but processing is not completed. If it used similarly for 4xx like 400, then it gives there is a client error, client is not reachable. And if it use the suppose 403, like the 403 code for 4xx, it may use the forbidden. And if you use the code like 404, it gives the not found. So these are different codes. HTTP status codes are basically used. And then the HTTP different services is used for that. As said, the 403 and 404, they gives the different status like forbidden and not found. So you can see the HTTP, it is part 2. What is the purpose of this HTTP by 2 is a major revision to your HTTP protocol, that protocol specification. So the purpose of this HTTP part 2 or version 2, we say, to improve the HTTP performance by addressing latency issues that exist in the HTTP version 1 protocol. So this uses same header format like version 1, but and it uses some status codes. So there are many important features to this second version HTTP 2 that a cybersecurity analyst must be aware of that. So that is one is multiplexing and server push and a binary protocol and the header comparisons. So then the multiplexing HTTP servers and clients, they carry on the conversation called the stream for each transaction. Whereas your server push, the additional service, that HTTP servers are able to push content that has not yet been requested to their client. So the server anticipates the content that the client is likely to request. The client caches this content for future use. And another one is the binary protocol. In HTTP version 1, the commands such as request from client to server are made in text format, whereas in HTTP, they has the shifted to using the binary commands. So these overcomes some the cumbersome issues with the former version. So lower request and responses are overheaded. And then the next one is the header compression. So this HTTP request and response header are compressed to further reduce the amount of bandwidth required by your HTTP 2 by using the further gives the different reductions are there for that file. So then securing this HTTP, it uses the secure HTTP. We call that is your HTTPS service. So this protocol is used for the secure communication across the internet. So HTTPS use the authentication and encryption to secure the data first. And when authentication is there and the encrypted data exchange between client and your server, HTTPS use the same client request response process, but the data stream is encrypted with the secure socket layer or your transport layer security, we call the TLS. So encrypted data means when the data is encrypted, it uses the key. When keys are used, the server and client, they know the same key, whether using the asymmetric key or the symmetric key. For encryption and decryption purpose, that will complete with this secure socket layer and your transport layer before being transported across the network. So this HTTP S2 is specified to use as your HTTPS with security for encryption data purpose. So the confidential information is transmitted over the internet by using either private key for encryption or public key. So if same key is used on both the sides, we call that a symmetric key. If different key is used for your encryption purpose and for your decryption purpose, then we call that as your asymmetric key. We talk more about this later. Okay. So these are few services which we basically use in the network to understand the how the data is transferred from source to destination. In the next class, we'll try to discuss the network communication devices and how they are going to be used and helpful to protect the network. Okay. So these are few services we'd like to discuss. If you have any